The James Webb Space Telescope is exploring objects in a very early phase of the universe, where the most precise measurements reveal the existence of large, fully developed galaxies. This search leads us to question the hidden mysteries of the universe. The telescope has reached the edge of the known universe, allowing astronomers to go back in time and uncover an unexpected finding. About 6 million galaxies existed between 500 and 700 million years after the Big Bang, when the universe was still in its early stages. This discovery challenged previous conceptions of galaxy formation. It was expected that smaller, newly formed galaxies would be found in the early cosmos, but these measurements showed mature galaxies similar to our own, challenging previous theories about the early evolution of the universe. The James Webb Telescope uses infrared light to observe the universe, as its wavelength is visible to the human eye and captures the faint light emitted by ancient stars and galaxies, allowing us to literally look back in time to about 13.5 billion years ago. This amazing capability of the telescope paints a shocking picture. Mature galaxies at a time when the universe was thought to harbor mostly smaller galaxies. This finding challenges established theories of early galaxy formation, challenging 99% of existing models that describe these galaxies as clouds of stars and dust that evolved over time. When the scientists examined telescope data, they were perplexed to find such large, mature galaxies in the early cosmos. They were even surprised to the point of believing that they had initially misinterpreted the data, as these huge structures appeared surprisingly quickly in the image. The research team used spectroscopy to analyze the light emitted by these galaxies, identifying elements and calculate their actual distances. This method provides a more complete picture of these giant structures and their location in space, providing crucial information about their nature and origin. Despite this exciting discovery, scientists remain open to different interpretations. Although the evidence points to these being mature galaxies, there is a possibility that some of these objects are masked supermassive black holes, further challenging our understanding of the early universe. By analyzing telescope data, confirmed galaxies were identified as the oldest and most distant galaxies detected so far, dating back to less than 400 million years after the Big Bang, when the universe was still very young. These discoveries have been verified through expensive spectroscopy observations, allowing astronomers not only to study the physical characteristics of these galaxies, but also to accurately determine their distances and assess their evolution. The recent findings focus on 4 galaxies with a redshift greater than 10, confirmed by spectroscopy. A redshift of 13.2 indicates an approximate time of 13.5 billion years. The near-infrared camera and spectrograph were used by collaborating scientists to make these discoveries. The James Webb Space Telescope Advanced Deep Extragalactic Survey Program is an ambitious effort supported by 80 astronomers and scientists from 10 countries to study the most distant galaxies. The JADIS program spent more than 10 days observing a small area of the sky near the Hubble Ultra Deep Field, explored by astronomers for more than 20 years with virtually every major telescope. Nearly 100,000 distant galaxies were discovered, each billions of light years away. The JADIS team studied these galaxies in 9 infrared wavelengths bands over a 3-day period, collecting information about the gas and stars in them. By analyzing this light, they were able to reveal the characteristics and obtain accurate redshift measurements. This allowed them to determine the intrinsic luminosity of the galaxies and show how many stars they contain, helping to understand how they were built up over time. The discovery of these old and distant galaxies gives us the opportunity to better understand the early stages of our galaxy formation and how those initial processes have influenced cosmic evolution. The James Webb Telescope has provided revealing data on galaxies, planets, and stars, opening a unique window into the universe. The James Webb Telescope is expected to continue operating for at least 20 years and has already made significant strides in scientific research. It has discovered not only exoplanets and newly formed stars, but also the oldest known black hole. revealing detailed information about its formation and evolution in the early universe. The telescope uses infrared instruments to view the cosmic past and has detected massive black holes that grew rapidly in the young universe. However, how they appear so clearly in the history of the cosmos is not yet fully understood, posing a mystery to astronomers. This cosmic object emits faint radiation that has been reaching across the universe since its inception, generating a growing interest in astronomical research. The search for how black holes arose so rapidly in the early cosmos remains an enigma, although a primordial black hole presumably formed just after or even before the Big Bang is investigated so far, it remains elusive. Two main explanations are proposed for the abundance of black holes today. One explanation is that they could be remnants of giant stars that formed faster than present-day stars. The other theory suggests that they may have arisen from dense gas clouds that suddenly collapsed, forming these singularities in space-time. It speculates on the existence of a population of stars composed mainly of hydrogen and helium that formed shortly after the Big Bang and exploded, leaving behind black holes. Scientists are corroborating with the group that developed the MIRI instrument to detect an even clearer signal from the light coming from these distant galaxies. These emissions may provide information about the formation of the mysterious black holes in these galaxies and their cores. A set of 7 interacting galaxies has been observed, forming a protocluster, the most distant cluster of galaxies discovered so far. Simulations suggest that this system could become one of the largest and oldest clusters in the universe, with a mass nearly 100 times that of the Milky Way. The Young Space Telescope has revealed these findings, but it is not sensitive enough to measure the precise distances between these galaxies. It is like seeing cities from an airplane without being able to pinpoint the distances between them. However, it is expected that in the next 10 years, as technology advances, the discoveries will become more accurate. NASA's Observatory Telescope Institute plans to launch an instrument in the early 2027 that will facilitate the identification of galaxy clusters in the early universe, such as those found in this study. This new tool is expected to have up to 100 times the mapping capability of the James Webb. In the field of exoplanets, James Webb has been crucial. It has contributed to the discovery and study of numerous planets beyond our solar system. One of these is the planet whose name is HIP 65426b, a massive gas giant orbiting at a considerable distance from its host star, being 100 times farther than Pluto from our own sun. In addition, the telescope has captured amazing images, such as that of the M74 galaxy, showing structures in interesting space and details of stars and star clusters. It has allowed the observation of distant objects and has revealed fascinating discoveries that were previously difficult to perceive. What about you? What do you think? Let us know in the comments box. Remember to like and subscribe to the channel.